Corbin, would you take the first one for me, please?
Wait, what?
Take the first one for me, please, of the homework. Yep.
Okay. What's the sample space for each chance experience?
All right, so remember, when we're talking probability, guys, the sample space is every possible outcome. It's not asking for probability. It's asking for what are the possible outcomes. Okay. Jonas, flipping a coin, the possible outcomes are? Heads or tails, absolutely. Selecting a random season of the year. Georgia.
Fall, winter, summer, and spring.
All right.
Oh, Caesar. I thought it said.
Yeah, it does say season. You could argue in North Dakota we don't have all four of those, but typically you should have all four. Selecting a random day of the week. Kellen.
I put Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, except for this last.
Well, then where's this?
You forgot the weekends?
Yes, I think I
Yeah, you should have all 7 of them listed there for days of the week. Okay, question number 2. Brooks, would you read that one, please?
A computer randomly selects a letter from the alphabet. How many different outcomes are in the sample space?
All right, so now it's not asking us to list them kindly, it's asking us for how many there are. So how many different outcomes do we have in the sample space if we're referring to selecting a letter from the alphabet?
26.
26. Why is that, Kinley?
Because there are 26 letters in the alphabet.
Exactly, there are 26 letters in the alphabet. B, what is the probability that a computer produces the first letter of your first name? Colin?
126.
1 out of 26. Colin, does it matter what your first name starts with? No, because every letter has the same probability. Okay, 1 out of 26. I don't know anybody that doesn't have a name, or first name anyway. Question 3, Georgia, take that one, please.
Read it? Okay. What is the probability of selecting a random month of the year and getting a month that starts with the letter J? If you get stuck, consider listing the sample space.
All right, so we could write out all the months and then circle the ones that have a J. Maybe you know it off the top of your head. Jonas, how many? Start with J. Can you name them?
January, June, and July.
There you go. On how many months total?
12.
12. So 3 out of 12, and then of course we should always reduce when possible. So 1 out of 4. Question number 4. E represents an object's weight on Earth, and N represents the object's weight on the moon. If M equals 1 out of 6 E, what is the relationship between these two quantities? And now it's asking us some questions based on that formula. Does anybody know what the 1 over 6 would represent there? Brenna.
The weight of an object on the moon is 1/6 of its weight on Earth.
That's exactly right. Weight on moon. Would be 1/6 of what it is here. So anything you would weigh here, you would divide it by 6, and that would tell you the weight on the moon. Give an example of what a person might weigh on Earth and on the moon. Corbin.
120 on Earth and 20 on the moon.
Did you say 20 on the moon?
Yep.
That's correct. How'd you get that, Corbin?
I just divided 120 by 6.
Yeah, you take it divided by 6 because the, again, you mentioned what the 1/6 meant. So whatever your weight is, divide it by 6. Nice when you pick one that divides by 6 evenly, you don't have to worry about the decimal. Question 5, review from last unit. Autumn, would you read that one, please?
Here is a diagram of the base of a rotator, which is in the shape of a pentagonal prism. Each small square and the greatest one squared. The distance between the two bases is 8 inches. What will be the volume of the completed rotator?
All right, so we talked about this one a little bit yesterday. We reviewed the formula. Remember the most important part of solving these problems? Getting the area of the base correct. And we talked about a few different ways to do that. You could make it a big rectangle and subtract the missing pieces, or you can just split this. Colin, what was your preference?
Split it.
You split it. Triangle and square? All right, Evan, what are my side lengths on the square?
5 and 6.
Oh, so it's not even a square. Rectangle. Okay, so what's the area of that piece? 30. So now I got the triangle. Jessa, how do I get the area of that triangle?
Multiply the base times the height, then divide it by 2.
Okay, and what's my base?
6,
And what's my height?
4,
So 6 times 4 divided by 2.
12.
12. So my total area of the base, Veronica, is what?
32.
Not 32.
32 square inches squared.
Okay, so the rectangle is 30 by itself. What's the triangle?
42.
42, yes, 42. So 42 times the height. We read that the height was 8. So 42 times 8. Brooks?
336 inches cubed.
Y cubed, Brooks?
That is volume.
Correct. It's volume. So we need area cubed. Or label cubed. Find the surface area. A couple different options here. Again, you can figure out the area of every side. Add them together. Or you can figure out the perimeter of the base and take it times the height. Preference? What'd you guys do?
Area of every side.
Every side, all right. So area of every side, let's do the triangle facing us first. So this triangle would technically need to be drawn this way, if you want to look at it as the base being on the bottom. What is the area of the triangle? Chesney. 6, 3 times 4, divided by 2. So each triangle is 6. I'll just put that, the total of the triangles is 12. Give me an area one more side, Sophia. Left, right, or bottom, I would say.
The left side is 12.
Left side is 12, 3 times 4. Kinley, right side or bottom?
I'll do the right side.
Okay.
That's 16.
This is 4, and the bottom is 4. So the right side is 16. That leaves one side, Brody. What's the bottom? 20. 5 times 4. So 12 plus 12 plus 16 plus 20. Kinley.
I got 60 inches squared.
Anybody confirm 60 inches squared?
Yes.
All right, looks good. So surface area and volume, good representation of last unit. So you can go ahead and